The next aspect of periodic table that we need to treat now is what? Is block element. Block what? Elements. So all the elements we have in periodic table, they can be grouped into the what? Into the block element. So they can be grouped into the what? 4 block what? Elements. The first one we have we call it what? X block element. The second one is we call it what? P block element. The third one is D what? Block element. The next one is what? F block what? Element. Those are the what? The 4 block elements we have in periodic what? Table. But how are we going to what? To classify all the elements we have in periodic table into what? Into these block elements. It depends on what? The type of orbitals that housing the last electron in the what? In the orbital. What? Before you can know the what kind of what or block element does all these elements belong to, you will write out the what? The electronic configuration. So the orbital that is housing the valency electron of that element is where the what? The elements will belong what? Will not belong to. Take for instance now, this S block element, their elements, their what? Their valency electron can be found in the what? In S orbital. For S block elements, the valency electron of S block elements can be found in what? In S orbital. Take for example, now, yes, and this S block element can be found in what? They are elements of what? Of group what? Group 1 and what? And group 2. So all the elements of what? Of group 1 and group 2 in periodic table are called what? S block what? Elements. Take for instance, in group 1 we have hydrogen. Abi? So let's take it out here. We have hydrogen, which is what? Atomic number 1. Abi? The second one we have what? We have lithium, which is what? Atomic number what? Atomic number 3. The third one here, we have what we call what? Sodium. We have sodium, which is what? Atomic number what? 11. And the fourth one is what? We have what? We have what we call potassium atomic number what? 19. So I said group 1 elements and what? Group 2 elements, they are S block what? Elements. Because their valency electron can be found at what? At S orbital. Let us check it now. For this hydrogen, we have 1x1. This configuration. For this lithium, we have 1s1 and 2x1. Abi, for this sodium, we have 1s1, 2s2, 2p6, 3s what? 1. For potassium, we have 1s1, 2s2, 2p6, 3s2, that will be 10, 12, 3p 10, 12, 6, 18, and 4s2, 4s what? 1. Look at what? The last electron of all group 1 elements can be found at what? S orbital. Therefore, these group 1 elements are what? S block elements, because their valency electron can be found at what? At S orbital. Let me just take what? One example on what? On group 2. Let me take what? Magnesium. Magnesium is what? M what? Magnesium is Mg12, which is what? 1s2, 2s2, 2p6, and 3s what? 2. And 3s what? 2. You can see that what? For this magnesium, for barium 2, there is first valency electron can be found at what? S orbitals. So S block elements are elements in which their valency electron or outermost electron can be found at what? At S orbitals. An example of S block elements are what? Group 1 and what? Group 2 elements in periodic table. The next one is what? We have P block elements. So the P block element here, they are elements in which their what? Their valency electron can be found at what? At P block. What are the example of P block elements? Example of this P block element, we have what? Element of what? Group 3 in periodic table. Let me write it straight here. Element of what? Of group what? Group 3 in periodic table, group 4, group 5, group 6, and what? Group 7 elements. So these two, group 1 and group 2, the two of them are what? Are S what? S block. But from this group 2 to what? Group 7, they are called what? P block elements. So let us take aluminium, carbon, nitrogen, oxygen as case of study. Let us look at what? The configuration for what? For aluminium. Look at aluminium is 13, which is what? 1s2, 2s2, 2p6, 3s2, and 4p, 3s2, and 3p1. The final electron or the valency electron of aluminium can be found at what? At P. That's why boron and aluminium, they are what? They are P block. Let us look at what? Let me take carbon. 6, 1s2, 2s2, and 2p4. The next one we have what? Let's take fluorine. Fluorine is 9. Is what? 1s2, 2s2, and 2p5. That is what we call what? Electronic configure what? That is a P what? P block element. And again, this S what? Combination of S block elements and P what? P block elements, both of them are called what? Representative elements. They are also called what? Representative what? Elements. And D block elements, they are elements in which their what? Their valency electron can be found in what? In D block. Their outermost electron can be found in what? In D orbital. Example, we have what? Scandium, we have vanadium, we have iron, we have zinc, we have copper, we have manganese. That is, these D block elements, they are element of what? Of transition, or they are transition what? Elements. They are transition what? Elements. So all transition elements are what? Are D block elements because their valency electron can be found in where? At D block. If we write out the what? The configuration for what? For scandium. Scandium is atomic number what? 21. Eh? If you write it out, you have what? Is partially fill what? D block. And the last one here is what? F block. F block are elements of inner transition elements in periodic table. So that is what the block elements we have in what? In periodic table. So to determine the what? The block elements is we write out the what? The configuration of that element where you see the what? The valency electron, it we determine the block where the element belong what? Belong to. So the last aspect of what? Of this topic now is what? We are done with periodic what? Table. So if you want to study periodic table deeply, that one is what? Is the another aspect of the chemistry called inorganic chemistry. So now our next interest is what? Is periodicity. So let us look at what? Periodicity of what? Of an element. So after periodicity of element, we are done with what? Periodic table. Let me rub this side.